Happy Thursday. Welcome back. Did you get a chance to look at your homework? You should have, if you turned it in on time, I should say, not everyone has, you should be able to see your feedback, what you missed, and happy to answer questions about any specific problems you may have had.
Do I see the feedback? Much better.
Where is the
Do I
feedback?
see the feedback on icon or?
No, it's not an icon. So if you log back into the homework system and you click on that assignment, it should say view submitted work or something, and then you will be able to see your correct answers are in green font, incorrect is red italics, and as well as your points that you earned for completing it as well.
Thank you.
So, yep. Yeah, icon I don't really use for anything other than collecting quiz answers. I keep a separate spreadsheet of grades, and that your current point totals will always be on the landing page when you log into the homework system. Yep. All right. Let's see, I sent an email yesterday with announcements. So we did homework, that was the first one. Formative assessment number 2? Due Monday. Yep, and Erica's going to talk about that. Yep, it's her turn. Let's see what's next. Then one more homework 2, then will be due on the 8th. So I pushed that back already. No class next Thursday, office hours instead. I think that's all the announcements we have. Project outlines, I need to make that. My goal is to make it by tomorrow and post it. But if that doesn't happen Monday at the latest, that way you can see what you will need to submit. That will be due soon-ish, I think. Let me look. I'm not going to rely on my memory. It's just too dangerous at this point.
Is it past the 8th?
Yes.
Okay.
It should be, based on the rotation. The 13th.
Oh, very good.
Yes. So my plan, by the way, is to get your outlines, get you feedback on them before I leave for my conference the following week. That way you can be working on stuff for your project while I'm gone. But basically the outline will be what's your data set, like what's your sample size, what's your design, what are the variables like, what do you want to know? So it's really just a checkpoint to make sure that what you've selected is appropriate for the class in terms of the design. It needs to be something multi-level, and I'm being pretty flexible on that score. And then to try and point you towards additional pieces that you might need. So for example, if you want to predict a binary outcome with multi-level models, you can do that. The models that you need to do that, though, need to be adapted based on what is in this class. Like you would have to add the logit part. And if you already know what logits are, you'll be like, oh, okay, I can do that. But if you don't, then I might steer you a different way if I have choices like that. So, yeah. So yeah, then we have a pseudo fall break while we go to a conference. Notre Dame, as it turns out. No one's listening. Like, yeah, I'm going to Notre Dame for my conference. Aren't you excited for me? Indiana is really beautiful in the fall. Just like Illinois or Iowa or Kansas or Missouri.
Just go a little bit farther north right now.
Yeah, exactly. All right, then we were talking about smush slopes and variance explained by slopes and stuff like that. So should we back up and review some things? Please, that would be good. Get us all back on the same page. So in a nutshell, why are level 1 predictors in multi-level models complicated? That's my big picture question for you to start things off. Why are level 1 predictors more complicated than level 2 predictors?
Because they can have both level 1 and level 2 variances.
Yep, because they're both, is the answer. If a predictor is measured per cluster, we know that it is only at level 2. It only has between cluster variance. That's the only role it can play in the model. If we have predictors measured at level 1, those are people things. To the extent that people are not randomly assigned to their clusters, people things become cluster things. Some schools have more money. Some teams are more functional. Some countries have better resources. Some states are more egalitarian. You can think about the cluster as being composed of people. So to that extent, people things become cluster things. So our job is to make sure the model understands that every people predictor is also a cluster predictor. So that's the basic premise. for the same reasons that we would use multi-level models to predict outcomes that have multiple dimensions of sampling. We would need to worry about how to specify level 1 predictors that contain multiple dimensions of sampling. Same deal. Okay, how's that feeling? That much. Now, how we do it and what the numbers mean is the tricky part. So we started talking about cluster mean centering, and we had not yet talked about the alternative very much. Does that sound about right? This is slide 10 in lecture 3.
Thank you.
Yes.
I was trying to read.
The tiny little 10 in the bottom of the screen.
Well,
that's being
no,
logged.
the smaller top left where it says the name of the
Oh,
file.
yes. Yes. I put underscores in my names because back when I started doing things, when you downloaded things from the internet, it put like weird symbols in between if you had spaces, and so I just got in the habit of underscores. But yes, class, lecture, underscore, topic. That's my naming format here.
Perfect.
Lecture 3, there we go. So let's talk about cluster mean centering for a minute, since that's what we had examined before.
Mhm.
So cluster mean centering is the idea of carving up the level 1 predictor into level specific versions by brute force using observed variables, and then sticking those level specific versions in the model as predictors instead. So at level 2, what goes in is the cluster's mean of that level 1 predictor. So in terms of notation, it's L1x is my generic name for a level 1 predictor x with a bar, meaning it's the average of it for cluster C. So each cluster gets a mean computed across the rows of its people. That mean is then appended to the data set to be used as a variable. And because level 1x mean may not have a meaningful 0, we would subtract whatever constant you feel like so that it does. So this step is optional. In the example that we're working with right now, SES somehow magically had a grand mean of 0, so I left it alone. But in general, you want to pay attention to this for the same reasons as usual to ensure a fixed intercept that has meaning. So if I were to pick, for instance, the sample mean of this cluster mean level 1x variable, positive values would mean that my cluster is higher than other clusters on average. Negative values would mean that I'm lower than other clusters on average.
Would the mean that you use there not be the grand mean, but the mean of the clusters?
The mean of the cluster means, yeah. And I don't think that distinction should matter much in practice,
And would that be a weighted one or not? Depending on how close the sample or sample clusters
it
are?
would be the weighted version because you're first computing a mean for each cluster and then you get the mean of the means.
Okay.
So then the clusters are equally weighted in that sense.
Okay.
Yep.
Cool. Thank you.
So we have then cluster mean x in green here is functionally a level 2 predictor, the same as any other cluster characteristic.
Mhm.
This is the mean of that variable for this cluster. It characterizes a cluster's standing relative to other clusters. At level 1 then, we get the part that was intended by asking everybody this question, the people variance. So we're isolating that by creating a new variable that I'm calling within cluster x. Note that it has a PC because it's per person per cluster. And that is formed with the original level 1 predictor minus that uncentered cluster mean. So then this variable, when someone is a 0 value, that means they are at their usual for that cluster, their average with respect to their cluster. And as we talked about last time, if you go to a rich school, then an average car might be an Audi, and my crappy Corolla would make me poor by comparison. But at a different school, my Corolla might be awesome because that school does not have people with cars. So we don't know what's up in terms of an absolute amount of this variable at level 1. It's all relative to the cluster. The absolute amount that person level variable is deviating around is in the level 2 model. So we're not losing information, we're just partitioning it into the 2 parts. Yes.
So it's like you're centering the cluster's individual people with the cluster mean.
Yes, we are literally subtracting cluster mean differences.
Right.
So that what's left is purely level 1.
Okay.
Purely within cluster variance.
Mhm.
So think of it this way, if you only had like one cluster, if you had one school, this is the information that you would have.
Mhm.
by sampling multiple clusters, multiple schools, you're adding this additional piece. And so it makes sense to relegate cluster differences in this predictor to the level 2 model where it belongs. 2 thumbs up. Okay. So a 0 value means you are normal for your cluster, whatever that is. A positive value means you are higher, negative value means you're lower. And I like doing it this way because each of these is unambiguous as to what its slope means. The only kind of variability we have at level 1 is within students from the same cluster, people from the same cluster generically. So that's all it can mean. This is a within cluster effect, the end. Likewise, the only variability that cluster mean X has is across clusters at level 2. Its slope only can represent between cluster differences, and that's it. And if you leave either of these out of the model, you're assuming that slope is 0, the same as usual. Anything that's not in the model is assumed to not contribute. That's just standard practice. So I like this because the interpretations do not depend on what they're paired with, and they're very straightforward, and you know what to expect in every case, and that becomes even more important when you fit interaction terms, because those can be smushed too. Good times. All right, so then in equation form, if I were to put in main effects of the pieces of my level 1 predictor, the cluster mean centered part goes in at level 1. So I have beta 1c as a new latent variable or placeholder for how each cluster would get its own within cluster slope with this x variable. Right now, it only has a fixed effect. So we're saying every cluster has the same relationship within clusters. The effect of having more x than your peers is the same across clusters. That's what this model says. Now, you might imagine that's a testable hypothesis. The idea as to whether each cluster needs their own is a random effect. So in the same way that we had U0 here as a random intercept by which each cluster gets their own intercept, we can eventually, not today, but eventually add in a corresponding U here, which would become U1, given that it's associated with beta 1. And that would allow differences between clusters in what that x slope is. That's coming. That's unit 4. That's a big one. But for now, what we have are 2 main effects. And I would say, even though in terms of the notation, it looks like all of these fixed effects are in the level 2 model, gamma O1 right here, I would call that a level 2 fixed effect because it's multiplying a level 2 variable. Gamma 1O is multiplying a level 1 variable, so I would call that a level 1 fixed effect. And because they are uncorrelated, each of these represents the full association of that x with that y at that level. There's no like collinearity, there's no competition, like it just is what it is. They are not perfectly uncorrelated if you have missing data though, and you form the cluster mean with some cases that don't eventually get used at level 1. So that's where it gets a little bit tricky. Conceptually, this is what we're doing. So I'm using circles on the y side of this picture to indicate latent variables, meaning things the model is figuring out as part of the process, random intercepts and residuals. So I have an original y outcome that the model splits into level 2 versus level 1 in terms of its remaining variability. Then I have my x variable that I'm splitting. So cluster mean x as a level 2 predictor is conceptually the same thing as a random intercept. It represents the cluster mean. A random intercept represents mean differences. It's the same idea. At level 1, the within cluster deviation, so creating that cluster mean centered version that only has relative peer-to-peer variance, that is conceptually the same thing as a level 1 residual on the y side. So we're doing observed variable versions that split x into level-specific pieces in the same way that the model split y into level-specific pieces. And if you're looking at this, as I noted at the bottom, and saying, why do I need boxes over here when I have circles over here? Yeah, good question. Well, the short answer is that takes different software that's harder. The longer answer is, in traditional multi-level modeling, the software predicts one column. And so there's no way to ask the model to split out both of these things at the same time. There's ways to trick it, but it's suboptimal and there's very few choices once you get it tricked. So in multivariate multi-level modeling, or what is known more fancy as multi-level structural equation modeling, that's the big fancy word, then you can ask it to split out the variance of x in the same way that it split out the variance of y, and these would both be circles. So that's a multivariate version of the model that would be better in theory, but because you're trying to estimate more things at the same time, it also needs more data. So that can be a limiting condition.
So I just have a question about the centering of the cluster. So level 1 x c hat is the mean for the cluster in relation to this level 1 predictor, right?
The bar, not hat. The
Yeah,
hat is
bar.
this one, yeah.
Sorry.
Yeah, level 1
That
x
would-
bar is the mean across the people
Yes.
from that cluster.
From that cluster. So that will change depending on the cluster.
Exactly, exactly.
So, and C2 is a constant that doesn't change in relation to the cluster, right?
That's right.
What is C2 then?
C2 is your choice. So let's say that I have an outcome that's measured on a 1 to 5 scale, and I'm pretending that those are numbers. A cluster mean of 0 doesn't exist on a 1 to 5 scale.
Mm-hmm.
But I might pick 3 and say for a cluster that's at the midpoint with respect to whatever this means, then I would say that's my representative cluster, that's who the intercept would be for. And so then if I'm a cluster of 4, my score would be +1 because I'm one above the mean that I picked to center at. But someone else might say, no, you shouldn't pick 3, you should pick 4. Okay, whatever. It's just the idea that it needs to be within the scale of the data, so the fixed intercept has meaning, because the fixed intercept is when the predictors are 0, so 0 needs to be within the range.
Okay. It makes sense that it has to be the same scale. So it's completely subjective what I'm going to choose to be C2?
With respect to C2, yes. You can not do it or you can do it. The model will fit the same. You won't have any issues. It's just a question of what you want the fixed intercept to mean for sure.
Oh, okay.
Because that's when your predictors are 0. So like you would say, oh, this is the expected outcome for a cluster who has a mean of 0 on my 1 to 5 scale. Right? That's not wrong, but it's weird. And if you have interaction terms, then you have main effects that are specific to the 0 value that doesn't exist. And that gets even weirder.
That makes sense.
Yeah, okay.
And
Thank you for the questions.
And if I'm remembering correctly, and I forget things sometimes. I think that you said if you had a third level, then instead of C sub 2, it'd be the average of your level 3s that feed into your level 2s.
That's right.
Okay.
Yep, and it would keep, like a Jenga
Okay.
tower, keep going up and up. Yeah, no, that's a real,
I didn't mean to blow your.
yeah, my
your
head just
guard
broke
up.
too,
You
no
just did.
worries.
But it's also nice. I want to make sure I had that full picture. So because if you do have 3 levels, which I'm sure happens a lot,
Mhm.
you need to know how to handle that.
Well, yeah, because then guess how many pieces every level 1 predictor has in a 3-level sampling design? 3. So this gets real ugly real quick because like in a 3-level design, if I have a level 2 predictor, it has level 2 stuff and level 3 stuff most likely. So every predictor is at least one thing to start with, but possibly 3 things. And if I wanted to examine moderation, so like I'll use Vladimir's story we were talking about, Rong-Su's data. We have people nested in years, nested in states. And what you want to know is the gender gap between men and women when they apply to college and what they want to do. What's it a gap in?
Vocational interest.
Vocational interests. Okay, something about jobs. Sure. So that means then that is the effect that they care about, and they want to see how various things moderate it. Well, the extent to which there's a gender difference could vary depending on what's going on that year. Like maybe there's an economic downturn, or God forbid a woman is elected president someday or something and we change our job expectations. I know, it's crazy. Maybe in my lifetime, we'll see.
Had a VP.
Or state things. Maybe there are fewer gender differences in some states and more gender differences in other states because of whatever things are happening in those states. So that's level 2 interactions with that predictor and level 3 interactions with that predictor. So it, like even interaction terms get exponentially more of them because you're having to cover all the levels. So that's why in your projects, by the way, I'm gonna ask you to pick like 3 variables or something, right? Because I don't want that creep of things to happen to you, because every variable is gonna be potentially 2 things. How's that? Woo. But what your question was, like, this is the most important point here. This little c is doing a lot of work. Like, it's tiny, right? It's a subscript. But yes, we are subtracting a variable because the level 1 x bar mean thing is going to change across clusters. And that's why I'm saying that we're subtracting all the cluster information out of this. Because somebody who has a 1 on this variable is 1 above their cluster. But we don't know what 1 means in an absolute sense. They're just more. You're richer. Richer than what? Everybody else. What are they? Oh, they are up here. What they're relative to is in the level 2 model. So this is the biggest thing. This little c right here is such a big deal. And perhaps it's an unfortunate coincidence that I picked big C for constant, but I couldn't come up with anything else.
D.
All the letters are taken by other things. So this is my preferred way of thinking about it. You can make circle versions out of this if you have access to a multivariate version of the model. That's where I was going.
Way off left field. Chartreuse.
Chartreuse?
C. Clustering. Chartreuse.
Char-
Green.
Is chartreuse green?
Yes.
Okay,
I looked it up.
Okay, I'll take your word for it. Is it the same kind of green?
Actually, it's very close.
Okay. let's
Maybe,
go with
maybe
that.
I can show you after class.
So I can say purple pretty well, but chartreuse is going to be a little tricky for me. Is it just me or is that word hard? Let's all practice chartreuse.
Chartreuse.
Char-
like a snake.
Chartreuse.
Truce. There you go.
There we go. Chartreuse.
Truce.
That was difficult.
That's hard.
Yeah, I know. All right.
All right.
How about some pictures? We like pictures?
It's easier than chartreuse.
Yeah, let's go with pictures. So I have some just hypothetical plots here trying to illustrate between versus within and how that maps onto these models. So my fake example here, I have student math as an outcome on the y-axis. I have student reading as a predictor on the x-axis. We want to know how reading is related to math. Cool. Now I am varying school mean reading as well. So the red line is for a school that has a mean of 4. Green, chartreuse, is for a mean of 5, although this is closer to like a...
That's more than you.
Never mind. I'll let it go. And then blue is for 6. So the yellow dotted line through the means, that is conveying the between cluster effect. For every unit higher your cluster mean is than other clusters, in this picture, the outcome would go up by 1. So the slope for cluster mean reading is 1. That's how I generated this plot. So clusters who have higher average reading have higher average math, as we might expect. That's what the slope of this yellow line is. Per unit increase in the cluster mean. That's what the level 2 variable means. Within clusters, though, I set the slope to be 0. So if I go to a school where the mean reading is 4, but I'm a 5, doesn't matter. If I'm a 3 instead of a 4, doesn't matter. So this would mean that within school differences in reading have nothing to do with the within school differences in math. But schools who have better readers have better mathers. Can I say that?
Sure.
Can you be a mather?
I math her all the time.
You can now. So this is unlikely to happen, but it's a possibility. Here's the opposite possibility. Camera 1, camera 2. Camera 1, camera 2. This one is all within no between. So here, the line through the school means is flat because there is no change in math predicted from a 1 unit increase in school mean reading. So it doesn't matter what school you go to. Within schools, though, if I'm a better reader, I'm a better mather. And that is true regardless of what school you go to in this picture because I'm not introducing any kind of interaction term that would allow it to vary.
And that would be like a goal of a school district, for example. You'd hope that the that doesn't change if you go from one school to another.
If I am the, like the principal of a school or something, I'm an administrator, that would be good news. If I'm a real estate agent and I want to brag about how good the schools are in the neighborhood where I'm trying to sell my house, that
That's
would be
bad.
bad news.
Fair enough.
So, how about, no, I do have a picture. I have a picture of some of both, but I think I saved it for later. I got more pictures. So, here's syntax that would allow you to estimate these models. We've looked at an example of that. Let's do this example right here. So, we have, this is language being predicted by verbal ability. So I have like a language achievement outcome in this data set, some kind of measure of verbal ability. You would think they would be related. So yeah, fab. So in this model, I have one level 1 predictor that has been cluster mean centered. So I have the original verbal score minus the cluster mean right here. That is given a fixed effect. In this example, I previously had the amount of homework a school does centered at 2, whether or not it used mixed grades. And then I'm adding the verbal cluster mean here centered at 10 because that was near the mean for this variable. So then in terms of the output, the intercept would be for a school that gives homework of 2, doesn't use mixed grades, and those two things don't matter. Well, mixed grade matters a little bit, it looks like. Schools that use mixed grades are lower on average in language. And then these two ones here, it's the same variable, but one slope at each level. So we have to be very careful in thinking about what 1 unit is here, because that's our only hope in keeping them straight. So cluster mean verbal 10 is what I have called this inside SAS, which means this thing here. The cluster mean of verbal centered at 10, that's my naming convention. For every unit higher average verbal. So in the
School
cluster
average.
mean, yeah, the school average, for every unit higher the school average is, school average language goes up by 3.6. So this is schools. Schools who have students with more verbal ability have higher average language outcomes too. Schools with, clusters who, like I would write sentences that put the subject in to keep the level of inference in the reader's mind. So that gets to like the Zillow listing. Like, am I in a good school? Because as measured by the fact that all my peers do well, on average, yay me. My whole school's language goes up by 3.7. Now within my school, for every unit higher verbal I am than my peers, whatever that is, but just higher, then my verbal goes up, my language, goes up by 2.4, mine. That's a level 1 shift. So 3.6 is a level 2, shift the whole school up and down. 2.4 is level 1, just shift the person's score up and down. Question? Comment?
I just gonna say that reminds me of like tractors with their high gear, low gear, and you have the 4 gears. It's like, which one are you?
Okay.
You shift between the two and then shift them again.
Never having gotten on a tractor, let alone driven one, I'll let you go with that.
Done that a few times.
Yeah, I'm from the Midwest, but I'm not from the farm. That's what I would say. I'm from Omaha. Or thereabouts. A 4-hour radius of Omaha is where I claim to be from. But yeah, you can, whatever analogy helps you to make it work here. Question?
Lisa, can you go back to slide 15, please? I have a quick question because I think that there we have a contextual fixed effect hidden, right?
Yes, you do, but I haven't introduced that yet.
Okay, good.
That's coming.
Okay.
Yes, he's asking about the
Patience.
contextual fixed effect. which-
Patience.
Yeah.
Okay, I can wait.
Yeah. Yes, indeed, we do. All right, so 3.6 versus 2.4. Do those look close enough to you, like they could be the same number, or do they look like they should be different? Just eyeball it. Difference of 1.2, standard errors are smaller than that.
I think they're different.
Yeah. Well, it turns out I did a hypothesis test for that. 1.237 is literally the difference between these numbers. Between minus within. That's what Vladimir was just talking about. That's the contextual effect in this picture. So it has a standard error of 0.277, which means that it is significant at p less than 0.0001 in this case. Said differently, I have empirical evidence that smushing the slope is not okay. A smushed slope says the between slope at level 2 is the same slope at level 1, so it's okay to do that.
Would that mean, for example, let's say that we did not reject our null there. Would that mean we would only use 3.6, 2.4, or some middle ground middle, or would we add them together and just leave it?
If we wanted to, if that hypothesis test were non-significant,
Yes.
and that means that smushing was acceptable, which, by the way, I will never say is okay, but other
But
people might.
but just for the,
Yeah. Like theoretically, I just am no for that. But yes, other people would disagree. In that case, what you would get between these two is a weighted average.
okay.
And it would be much closer to the 2.4 because there's a lot more kids than there are schools. But then the problem would come in is that the model says, well, the level 1 and level 2 slope combined is like 2.5 or something. But we know that the level 2 one should be 3.6, which means the level 2 model is misspecified. So that means what you end up with, random intercept variance left over, is going to be wrong, effect size is going to be wrong. And I've actually seen it like cause problems like
Throughout the whole model.
yeah, like especially if these are in opposite directions, which can happen, and people do that like for demonstration purposes. There's another example I like about when these effects can happen in different directions, and it is repeated measures of typing. So if you think about speed and accuracy of typing,
Mm-hmm.
people who are good at typing are fast and accurate.
Yes.
But when you're rushing, relative to how fast you normally type, your accuracy goes down.
Inverse relationship.
Mhm. So within persons, I would expect a negative relationship between how fast I'm currently typing and how accurately I'm currently typing. But between persons, I would expect those to both be indicators of skill, positively associated. So I like that one too. Ellen Homaker used that in a talk, and I don't know where she stole it from, because I've heard that other times too. That's the most recent place I've heard. So yes, a contextual effect is interpreted several different ways. I think the most obvious from a stats point of view is right here. It's literally the difference. It is how much more positive the between effect is than the within effect in this context. It is more positive by 1.2. I would not say that it's stronger though, because these x's are not on the same scale. These are unstandardized slopes, so we can't say numerically that 3 is more than 2 because it's 3 per unit, and a unit is a cluster mean difference as opposed to a unit of the original variable for purple. Different units. Yeah. So yeah, here's all the words. In this example, the random intercept variance was reduced by 53%. The inclusion of the level 2 predictors and the level 1 variance was reduced by 35%. And so I note here, of the original for context, in this example, we started out with 22% between school variance in language. Of that 22%, we got 53%. So we
So
got
around
like
10%.
like 10 or 11%, somewhere in there, of the overall data.
Okay.
Likewise, of the original 78% that was between students at level 1, we got 35% of that by the model. So pseudo R-square are per pile effect sizes, or I think of these piles of variances, the circles. So how well did the model do at explaining between school mean differences? That's one number. How well did the model do at explaining within school student differences? That's another number. What's next? Okay. Contextual effect is what's next. We knew that.
Ooh.
All right, how are we doing, folks? I read an article in the Chronicle of Higher Education this morning that said that I should not ask, do you have any questions?
What
I should
questions
ask,
do you
what
have?
questions do you have?
Yes, I've heard that one.
What questions do you have? What are your impressions?
Lisa, in the interpretation of the within cluster fixed effect, at the end there you are saying per unit higher verbal ability than their school mean.
Mhm.
We know that we are using cluster mean centering, so we have within and between fixed effects in our model. Although we are not conditioning the within fixed effect on anything. We don't have a cross-level interaction, for instance.
Correct.
So to me, right now, the last part, than data school mean, could we just use higher than the peers in that school? Because to me right now, it sounds like the fixed effect at level 1 is conditioned on the school mean. Although we know that we could change, for instance, we could use within cluster fixed effect and contextual fixed effect, so the level 1 variable wouldn't be conditioned on the school mean, would be conditioned on a constant, and the level 1 fixed effect would be the same numerically, right? So that last part, than data school mean, do you think that's needed, or in this case we could do something like just more than their peers in that school?
So the question was about the wording on the end of this line here. So BC, by the way, stands for between cluster, WC is within cluster.
Okay.
A within cluster slope is, I labeled it as the difference in student language, so that's my Y, per unit higher verbal ability. And so I added the than your school mean to be crystal clear as to what higher than, like what the point of comparison was. But you're right in the sense that it's just higher because it is one linear slope that is not conditional on anything else. And so it kind of doesn't matter where you are to start from,
Exactly.
one unit higher has the same impact.
I got it.
So
Okay.
yes, I agree with you, but I was trying to keep it like, keep the units emphasized. Like, what does it mean to be higher? It means that I'm from a school with more, like, whatever. And what it
Exactly.
means to be higher here is I have more whatever than my
Yes.
school.
Okay, great.
Yeah, the
Yeah.
subjects is what I was trying to like emphasize there, the subject of the sentence.
Yes, yeah, because in that case, to me, that makes sense. Well, that's especially important once you have those level interactions in your model, because that thing will be conditioned on
That's
the
right.
interaction. Okay, got it.
Yeah,
Thank
but
you,
that's unit 4, so that's definitely not today.
Lisa.
Yes.
But,
Question?
What's the impact? Because I'm thinking about centering. So anytime you have centering, then your reference becomes the value you are centering, using for centering. And in this case, we are using the school mean for centering. So which means for the computation, anything you have is going to be above what you are using for centering. So I'm a little bit confused now. Is it their school mean, because that is what we are using for centering,
Yes.
or
That is what I would interpret. It's because we are centering using the school mean verbal, then it's 1 unit higher than your school mean. But I think what Vladimir is saying is that, like, if you picture the regression line, it doesn't matter if you're at the mean and you're moving up 1, or if you're already at 3 and you're moving up 4.
Exactly. Yes.
It's like you're just higher is all you really got to track. But I'm emphasizing like higher than what to try and drive home the point of what level the term is at. So you're both right. We're all right, I think. I'm just trying to emphasize a different like point about it.
In a journal, yours is probably better to make sure that you're clear with your reader. My opinion.
You would be surprised how many badly written papers of multi-level analyses I see
Well,
where they don't
that's
bother
what,
to
that's
try.
what I'm saying. That's what I'm saying. In a journal,
Yes.
yours is probably a clearer, more words, boring, better.
More words. Yeah, words for the win. This is where me and my husband will forever disagree. He doesn't like words.
Oh, I don't either, but I also like being clear.
But the rest of the word uses them, right? So we got to learn how to talk to people and to write. And it will be your ability to do that that gets you a job. Because ChatGPT can write code. ChatGPT can't use words very well. Question? No? Okay. What other questions do you have or impressions?
Can we go on to our next topic?
We can. We can indeed. Yeah. So, cluster mean centering. I like because it is the easiest to get right. You do the work ahead of time to set up your variables and then you know what they mean. So if I'm using cluster mean centering, what I get directly out of the model is a within cluster slope that says what is the impact of being relatively higher on X for that person's outcome. That should explain level 1 residual variance as a person variable. This is going to be captured by the slope of the level 1 predictor regardless of whether you put in the cluster mean. Now, I think it's weird not to, but it's not wrong. And I want to note here that the value of x that is being multiplied by the slope is the within cluster version specifically. So if I have a value of 2, that just means I'm 2 above the cluster mean. I don't know what that 2 actually means in an absolute sense though. That's because the absolute sense is over in the level 2 model where it belongs. At level 2, if I'm part of a cluster that has a higher x on average, then is my cluster's average outcome different? And so if that is the case, we should explain random intercept variance at level 2. And this has the same interpretation regardless of whether we put in the level 1 predictor. You can just use the cluster mean of something and not use the person version. Now what we don't have yet is this thing called the contextual effect. That's what we have not yet seen in great detail. That has multiple interpretations. The one that we just looked at is the second one here. Between, minus, within is contextual. So it directly tells you the extent to which smushing is acceptable. If the slopes are not different, then you could make one number do 2 jobs, and it should be okay. The other way to think about it is more conceptual. And this is, I think I mentioned this last week. We're going to take our kids that currently go to Wickham. We're going to pick them up with all their characteristics, good and bad, and go stick them in some other school. The contextual effect describes how much their outcomes are predicted to change just from being in a different context with respect to that predictor. So this is a linear combination that you can get out of your cluster mean centered model if you just ask for between, minus, within, and I show you how to do this in any package you'd like, or we can obtain a contextual effect directly from the level 2 model by changing what goes into the level 1 model. This is the craziest part. Okay, let me say that again. We can get a different version of the level 2 effect, the contextual version rather than between, by changing the variable that goes in at level 1. Same variable at level 2, different interpretation. Different variable at level 1, same interpretation. Like, what? No, seriously. Let me back up to linear regression. Can I do that for a minute? Back when life was good, single level models, no logits, no U's. Yeah, just the equation for a line. You know, it's beautiful. So in this case, I've got x1 and x2. And in regression, one of the first concepts we think about is the idea of a unique relationship versus bivariate. At least those are my words for it. If I have x1 and x2 that are uncorrelated, for instance, if I have an experimental design where I first assign people to treatment or control, and then inside each of those I further assign them to 2 levels of something else, then I have this perfectly balanced 2x2 design. I've set it up so that the 2 predictors, what group you're in for the first distinction, what group you're in for the second, are uncorrelated. In such cases, then x1 would carry, beta 1 would carry the full relationship between the outcome and this predictor, and so would the slope too. So like, if I didn't have x2 in the model, beta 1 would be the same. Because they're not fighting against each other for common variance, they don't have anything in common. So you set it up that way on purpose. Now this is lovely from an experimental design perspective. That's never going to happen to us in the real world. All of our predictors are correlated. So when they are correlated, in other words, I will get a different answer for beta 1 when x1 is in the model than when it's paired with x2 or when it's paired with x3 and x4 and x5. Because this is then the unique relationship of what x1 contributes to the prediction that is not already handled by x2 and vice versa. So whether the predictors are correlated changes what their slopes become when they're paired together or not. So if we stick with that point of view, then let's look at how we compose the variables under these different centering strategies and then what they must mean. So I've got 2 clusters here. The first cluster has values of 2 and 4 for 2 of its people, creating a cluster mean of 3. Second cluster has values of 6 and 8 for its people, creating a cluster mean of 7. Okay, so here's my raw variable. Here's the cluster mean I got to compute as the first step in this process. Now, I got 3 and I got 7. If I want to make sure that my fixed intercept has a meaningful value when my predictors are 0, 3 and 7 is not going to help me. So let's go with 5.
Using the average.
Yeah, it's fine. So now, the first cluster has a cluster mean of -2 relative to 5. The second one has a cluster mean of 2. Regardless of what centering strategy we picked for level 1, this is what goes in at level 2, the same variable. The cluster mean centered at some number, so 0 means something. Now, under cluster mean centering, the first option, the better option in my opinion, we have the cluster mean as what each of the original scores is deviating from. So I get a -1 and a 1 because 2 minus 3 and 4 minus 3. Likewise, I get a -1 and a 1 because 6 minus 7 and 8 minus 7. So we don't know from this column about the overall differences between the clusters. This column is only capturing relative variability. And this new WCX within cluster X variable will be completely uncorrelated with cluster mean X. So its effect in the model can only be the within effect. This can only be between. They're in separate levels. Now over here, this is what most people would call grand mean centering. I refer to it as constant centering more generally because it doesn't matter if it's the grand mean or 3 or 6 or whatever. What constant you pick is irrelevant. In this case, you are solving the problem that the fixed intercept is whatever 0 is for the predictors as a reference. You're solving that problem. So now if I just subtract 5, I would say my fixed intercept is for somebody who has a 5 on this X variable. But if you think about the information that's in this variable, it's still both, right? You just took the thing and shoved it over. You haven't partitioned the level 2 part out. So what happens is this column, cluster mean X, is going to be still correlated with this column because cluster mean X is still in here. So what happens when two variables that are correlated are put in the model at the same time? They fight. No. Okay, here we go. Here's what happens. So I am using the same color purple, even though the variable has changed, because what it's going to mean is going to be the same thing. Level 1x is the original variable minus some constant, and I have C1 here instead of C2 to imply that they could be different constants. It doesn't matter. 3, 6, 0, whatever. Doesn't matter. This still has all of the level 2 information and all of the level 1 information in it. But I pair it in the model with cluster mean x, which now has a different color because it's going to mean something different. This is the cluster mean of that level 1 predictor minus some constant. So if we just look at the boxes here, what does level 1x have that cluster mean x doesn't in terms of its contents?
Can you please repeat the question?
Say that again?
Can you please repeat the question?
I was going to ask the same thing.
Yep.
Very good.
So if we just focus on the contents of the variables conceptually, what does level 1x have that CMX doesn't? What is unique about level 1x relative to CMX?
One's dealing with the individuals within a cluster, the other one's dealing with the average of the cluster, and that's,
Yeah, and that.
is that what you're looking for?
Yeah, that's where I'm headed. Yeah. So level 1x, contrary to its name, has level 1 and level 2 stuff in it. Variation. It's just this. CMX has only level 2. So if the purple predictor has 1 and 2, and the other one only has 2, what does the purple one have that's unique? 1, exactly. So we end up at the same place as we did at cluster mean centering, but we get there a different way. In cluster mean centering, we removed the level 2 variation from the predictor in the first place so that its slope would only be the within cluster slope. In this approach, we didn't remove it, but the model did. The process of partialing, that's another word I have a hard time with. Statistical partialing, the unique effect after after controlling for the level 2 part must be the reflective of the level 1 part.
It's like the partialing where you referred to in generalized, like the part, or is it different partialing?
I intend it to mean like the Venn diagram version of regression where you've got your overlapping predictors and the model slope ends up reflecting just the unoverlapping part.
Okay.
Like that's the analogy I'm trying for here. The unique part of the level 1 predictor is the people information. And that's not over here. So therefore the unique slope that ends up being reported after controlling for cluster mean X is the within effect. So after putting in the cluster mean, we end up at the same place at level 1, regardless of whether you start there with cluster mean centering or you end up there through statistical partialing.
So, I know it's jumping classes, but it is, I think, sort of related. So, if you are working with confirmatory factor analysis, you would probably prefer the cluster mean as opposed to the grand mean because it's easier for you to have control of what's going on.
I'm not sure how to answer that.
Okay,
to be
fair
honest
enough.
with you. The analogy for if this were, you could actually fit this as a CFA model if your people were the indicators.
Okay.
And in that case, the factor would be the level 2 intercept variance and the residual variance for each of my indicators, which you'd have to hold constant across indicators because people are exchangeable, would be the level 1 residual. I don't know if that helps at all. But
That does, thank you.
Okay, that's where I got. Yeah, there's actually a 2003 paper that is, I don't think it's on your reading list, but I'm sure it's referenced, where they, like someone actually went to the trouble to figure that out and demonstrate it. Like you can fit multi-level models as CFAs. It's a pain, I wouldn't recommend it, but it's like possible. It was more of a thought exercise. Latent variables and random effects are the same thing. Okay, how are we feeling with this part? Even though we put in a different variable, through the magic of statistics, we end up with a within slope.
Yay.
Yay. Now what happens at level 2? You would think that because this is only level 2 between variation, it would be the between slope. But this is the unique effect of this predictor after controlling for the between part that's already still in level 1. So you end up with this weird extra between effect that is called the contextual slope. And that's what you end up with at level 2. Okay, I'm gonna just let that sit for a minute. So the contextual slope that you end up with is the unique effect of the cluster mean after controlling for the original information in the person version of the variable. So this is the additional incremental effect of moving from Wickham to whatever other school for my kid. After controlling for my kid, right? The original version of my kid with all the information in it. What is the incremental extra effect of the school through the cluster mean? That's what contextual means here. Do I have, okay, that slide might help. I'm not sure if it does. Do you want to hear any of that again or differently? Or do you want to try and say it back to me in your own words?
I want to ignore option 2. Bad.
Oh, it is, but that's how the whole world works. So, at least in cluster data. In longitudinal data, less so. All right, let me try a picture.
Directed effects, yay.
No, that was funny. Like 4 of you went like this at the same time. Like, oh, thank God. Don't make no more equations. I'm trying here. All right, so y side's the same. Okay, we got
Yes.
a variable that's part green, part purple. I'm sorry, I can't do chartreuse
That's all
under this
good.
circumstance. And then we still have the original version of level 1 that hasn't been split into its parts, okay? So if all we had in the picture were this box, and we give this variable one slope that is supposed to be predicting the person part and the cluster part, that slope is smushed, okay? Like we just have this much. We're assuming that it does both things adequately. What we are doing is hedging our bets by putting in this teal box here, which is the cluster mean, and it is correlated with the original predictor. And it carries an additional effect that brings us up to what the full between should be. So level 1 does part of the job because it still has green variance in here, but then we put in the cluster mean to complete it, to make sure that it's all the way up to where it should be.
Is that the cluster mean after you've shifted everything? Or is that the cluster mean before you've shifted?
This is the cluster mean of the level 1 variable centered at some constant.
Okay, so it's not necessarily after you shifted it up or down or whatever with your level 1.
I'm not sure what you mean by shift then.
So earlier you subtracted off like 5 and you have like a negative 3 and
Mhm.
everything. So that cluster mean there is not based upon the negative 5, negative 3. That's based off of the pre.
It's this one.
Okay.
So it is the same variable, I just put it in a different color since it's going to take on a different interpretation. That was my choice.
Okie dokie.
But yeah, this helps fill in the gap. This might help. Pictures, different pictures. Okay. So this is the same story. If you're a better reader, are you a better mather? Now I have added the contextual effect to the picture. So in this picture, the between effect is still given by the slope of the yellow line, and that is through the cluster means of these variables. So I have a mean of 4, 5, or 6 across these hypothetical schools. For every unit higher the school mean reading is, school mean math goes up by 1. That's the slope of the yellow line. So if I were to aggregate across the students from the school and do a school level regression analysis, this would be my answer. I would get a 1. At the person level, for every unit relatively higher I am, so if I'm a 5 instead of a 4, or a 6 instead of a 5, the change in my math is 0, according to this picture. The within slope is 0. Now the new one. The slope of the vertical line, which sounds as crazy saying it out loud as it does in my head. Can I say the shift? I don't know what you call this. This. Vertical distance. After controlling for the original amount of the level 1 person predictor, that's the key to understanding this. So conditional on a score of 5, period. Like if I can read 5, the contextual effect is the vertical distance between the schools at that point. So if I'm a 5 and I go to a school that has a mean of 5, I have a higher outcome than if I go to a school that has a mean of 4. So if me and my score of 5 transition to a new school, and that school has one more unit better reading on average, then the whole school has an increase of 1. So the between slope and the contextual slope are both 1 in this instance, because between minus within is contextual, 1 minus 0 is 1. How about this one? This is the opposite pattern. Now, what school you go to in terms of the means does not translate into differences of school math. So the 4 school, the 5 school, and the 6 school all have the same predicted outcome. Within a school, though, if I am higher than my peers in reading, my math is higher than my peers. Along the line here, if I condition at 5, students who go to a lower mean school actually are higher than students who go to a higher mean school. The contextual effect is -1 in this picture. 0 minus 1, or excuse me, yes, 0 minus 1 is -1. Between minus within equals contextual. 0 minus 1 equals -1. So this would be a situation in which if you misinterpreted the contextual effect for the between effect, you would probably come to a very wrong conclusion. So schools are actually working against you if you condition on a particular level of reading. Schools don't matter if you don't. So it's two different versions of what's happening at level 2 based on what you're holding constant. If you don't hold constant student scores, the between effect is 0. If you do hold student scores constant, the contextual effect is -1. Oh, another one? I got another one. Here's another one. This is probably the more common scenario. Between is 2, within is 0.5. So the slope of the yellow line through the means here is 2. For every unit higher school mean reading, school mean math is higher by 2. Within a school, for every unit higher reading than your peers, your math is higher by 0.5. And after conditioning on a particular value of student reasoning, for every unit higher school mean reasoning, school mean math goes up by 1.5, the difference between the two. So this would be a situation in which, does the school matter? Yes. 2. Does the school still matter after you control for the student on that variable? Yes, 1.5. Two different answers, different questions. In a lot of research, people want to know what the additive contribution is of your environment or your context. And so most research questions tend to be phrased as contextual effects. What is the extra impact of living in Iowa? What is the extra impact of being from this country instead of that country? What is the impact of the school you go to? There's a lot of examples of this. Yeah. Can you think of any examples from your world or question?
Yeah, so to identify the contextual effect, my understanding is that I could go both ways, right? Could use the grand mean centering, or do the cluster mean centering and then find the contextual slope by subtracting the between minus the within.
With respect to the fixed effects, yes, you can go either way.
But
But not with respect to the random effects that we haven't talked about yet. So yeah, in this model, there are 2 things that are going to be given directly, and you can get the third. So either way, if you've cluster mean centered your level 1 predictor so that it only has within information, you get the within effect. That's all you can get. If you don't, if you put in the constant centered version, but you control for level 2 by adding the cluster mean, you still end up with the within effect. Same result, even though it's multiplying 2 different variables because of the unique information. That's the thing that makes it different. At level 2 then, if I have the cluster mean centered version, I've taken out all the between variance. Therefore, the full between effect has to be given by the cluster mean. It has to do all the work. Whereas down here, part of the level 2 variance is still in this variable. So the cluster mean just has to fill in the difference as to what it should be. Code. No. Okay. 134. I know this is a lot. What's the one thing that you don't want to do?
Smush your slopes.
Hmm?
I said smush your slopes.
Smush your slopes. Can we hang on to that?
yes,
Now, what does it mean to smush your slopes? Explain to me how I would do that.
If you, well, a smush slope is when you treat something that has level 1 and level 2 variance with one slope, and basically saying that it's just one slope.
Yep.
Instead of treating it as separate like this, like breaking out what is the variance within the cluster and between clusters.
Yep. A smush slope assumes that one slope can do the job of the level 2 between and the level 1 within. That's a smushed effect. Let me, I want to go to a table that I like better than all this stuff. I'm going to find it first, though. Here we go. This is slide 36. We're just going to skip ahead for a minute. So here's a breakdown of the typology. This is from an article that I wrote with a former student where because we were covering both clustered and longitudinal cases in this article, I went with WB for my subscripts, within and between. So level 1, variable centered, meaning like person mean centering and longitudinal, cluster mean centering and cluster data. We set it up so that we have the original x minus the cluster mean then minus some constant. So if we look at what happens in terms of the interpretation of the slopes, if I only put in my within cluster mean centered level 1 variable, it gets a within effect, and I'm assuming the between is 0. If I only put in the level 2 cluster mean, it gets a between effect, and I'm assuming the level 1 effect is 0. If I put them both in at the same time, which I would say is the most reasonable thing to do, then I get both at the same time, but they don't compete, because I did the work ahead of time to remove the level 2 variance from the level 1 predictor. So this is why I like this. The bottom table is why I don't. So this is the original level 1x minus some constant at level 1, but still the same variable at level 2. If I forget the cluster mean, that's the smushed effect. So if I just put in level 1, centered at 5 or whatever, doesn't matter. If I just put in level 1 and I don't put in some representation of it at level 2, that's the smushed effect. And the problem is that we are assuming the between effect is equal to within. It's actually a level 2 misspecification most of the time. If I do the opposite, if I put in the level 2 cluster mean without the level 1 part, then I'm in the same situation as here, and it changes to between. And if I have them both in, it changes yet again. Level 1 changes from smush to within after you control for the cluster mean. Level 2 changes from between to contextual after you control for level 1. So you got to know what's in the model to know what you got back. That's the tricky part.
I like the first one. That's one less variable.
Yeah, I like the first one too.
One less variable. I mean,
So there was, some of you have heard this story before, in around 2011-ish, I was invited to go to a multi-level modeling conference in Utrecht, in the Netherlands, by Joop Hawks, one of the greats in the field, and I was very excited that he even knew who I was. Turns out he knew who I was because he Googled how to teach longitudinal, and my class came up. And that was why I got the invite, because he liked my slides. But I got to give a talk at this conference, and it was a conference of people who study multi-level models or use them all the time. Like 70% of the presentations were smushed. Like it was rampant throughout the conference. I just sat there going like, what? Like I thought here people would know better, but no, what you will see is a level 1 predictor all by itself, maybe centered at 5 or whatever, with nothing at level 2. So that's wrong, most likely, from either perspective, because it assumes level 2 and level 1 are the same. That's one way to think of it. The other is that it assumes there's no contextual effect. It assumes that once you know where your standing is with respect to other people, it doesn't matter what school you go to or what the characteristics of your group are beyond you. Like if I have a positive attitude at work, I'm going to go with the team-based research, right? That's good for me. What if I work on a team where everybody is positive? Even better, right?
yeah.
What if I work on a team where everyone hates their lives? Like my positive may not offset that, but either way, me and my positive attitude is not going to have the same experience if I work with a bunch of people who are grumpy versus people who are happy with their lives. That's contextual effects. If I go to a therapy group where everyone does their homework and shares like they're supposed to, I probably have a better experience than if everyone sits there like this and hates the process. Just making stuff up at this point. But you're with me, right? Maybe? Context matters, or at the very least, it's an empirical question.
Mm-hmm.
At the very least. So that's what we're going to do next week, is tackle that empirical question. Several examples, pictures, equations. But yeah, going back to all the way in slide 1 or 2, somewhere in there. What not to do. There we go. Stick in level 1 without something comparable at level 2. That's what not to do. What are your comments? What are your questions?
Unless,
Are-
oh, you go.
No, yours is more.
Well, I was gonna say, unless maybe you test and the ICC is like negligible and you're like, well, there is no between cluster difference.
Yep, that would be like, so that's step one, is to see what level of variance any variable in your analysis has. If the ICC is functionally zero, then it shouldn't matter because you only have within information, you can only have it within slope. Like if it were like 2% or 3%, I might do cluster mean centering just in case to make it like truly within, but then I probably wouldn't bother to put in the corresponding cluster mean because it wouldn't have any variability. It would functionally be a constant. And I would especially do that if I didn't have that many teams and I was worried about loading up, spending all my degrees of freedom. Any question, comment?
My question was, are you on track to the point where you don't think that you need to watch a video for next Thursday? That's way left field, sorry.
I'm not sure.
Fair enough.
Yeah, I know I definitely got enough to go through next Tuesday with stuff to spare. I will have to see if I want to either make a video or if I can find video from the last time that covers the same stuff adequately. I'll have to see. This is the answer.
Yeah.
Question, comment?
Yes, Lisa, about the use of cluster means of level 1 things. What happens in those cases in which we don't have the whole group in our sample? For instance, if we use this room, if this room is one cluster, let's say that we are 20, but just 10 persons are in the data set. So we can take the mean of those 10 persons, and that would be considered a cluster thing, a classroom characteristic. So let's say that we have percentage of females in the classroom, and let's say that's 60. That's 6 out of 10, the 10 who were sampled. But that would be considered a classroom thing, when in fact it is a samplish thing. In those cases, what do you think of the use of cluster means?
Great question. I have a little bit about this on slide 39. To the extent that you have a better version of the cluster variable, I would use it. So for instance, school districts publish information on the proportion of their students that get free lunch, right? Like that's a data set you can download from some government website. That is preferable than aggregating over the students who happen to be in your sample and characterizing their school mean cluster as free and reduced lunch from those kids, right? Because 10 out of 20 is maybe a representative sample, may not be.
Exactly.
So if you have better data on the context, I would use it, is the short answer.
In
Yes.
that case, Lisa, should these variables match to each other? What I mean is, could we center, for instance, the level 1 variable with this level 2 thing, or are those two completely
I
separate
probably
things now?
would not, because it's not gonna render the level 1 and level 2 uncorrelated in that case, because you're not centering around the right point.
Yes,
So yeah,
that
so
makes sense.
in that case, I would put in the original level 1 variable and then the level 2 proxy that's
Yeah.
more complete, and say that like conceptually it's like a contextual effect, but it's not gonna be in the same metric necessarily.
Although, Lisa, I think that doing that wouldn't separate the level 1 thing from the level 2 with respect to the original level 1
Yeah,
variable.
if you wanted to be extra certain, you would still cluster mean center at level 1 and then stick in the better version of level 2 as the between.
Yeah. Yes.
That would be
makes
like the
sense. Although
safest
that level
thing.
1 thing would be related to whatever the cluster mean in the sample was if we add cross-level interactions, unit 4. But
Unit
that's-
4, not today.
that's interesting. Thank you, Lisa.
Thanks for the questions. All right, 1:44, I'll be here for a few minutes if anyone wants to chat. Otherwise, thanks for being here. Like, no, it gets better, I promise. It gets better. Okay, hang in there. Have a good weekends, folks. Work on your next quiz and let me know if you need anything. Peace out.